Hi, this online lesson is on Year 8 Measurement Revision. So you can write this as a title. And we'll be covering our skills in length, perimeter, area, and volume. Now, let's just cover some expectations that I have of you during this session. I want you to write down any questions and draw any diagrams. There are 20 questions in this lesson. Attempt, so always try the questions yourself first. Don't just copy what I'm writing. Correct, so correct your work with a different coloured pen to show me that you have tried the question yourself first. And anything you may have gotten wrong, you can just correct it with that different colour pen. And gather, so write down any additional notes you may have missed out throughout this topic. So any new information you learned during this lesson, just write down those notes. Okay, the first few questions will involve length and perimeter, so you can write this as a subtitle. And question 1, look at the following shape. Find the unknown side lengths for A, and B, find the perimeter of the shape. So have a go first. Okay, we can see this shape is an L shape, and we have learned that an L shape was once a rectangle and a part has been cut out. And we have learned different ways on how to find the unknown side lengths and how it works. Okay, so for A, it asks us to find the unknown side length. So we can see we have an unknown side length here. I can call that just say A, and another one down here, which I can call it B. So I need to find the length of A and the length of B. And to do that, I have to use the information given. Now, if I focus on B, I can see that if I have this length here, which is 50 meters, which is also a part of B, okay? I just need this bit here, and I will have the length of B. And the length from here to here, I can see is 15, okay? So if I put 15 down there, it will give me the whole length of B, because B is that whole line. So it's just a matter of saying 50 plus 15 equals 65, and we're in meters. Okay, so side length B, because I've labeled it and called it B, I can just say B is equal to 65 meters, or if you read through the diagram, you can just put those measurements there. Now side A, so length A, I'll be doing the same thing. I'll be using the information given to find out A. So A, the length of A is from there to there. If I just highlight it, okay? So that means the length of A is also, I can show that length just here. It's a part of this whole line, which is 80, okay? So 80 meters is that whole line, and A, that length is just a part of it. So if I can subtract the rest of 80, if I can work out what that length is and subtract it from 80, it leaves me with A. And I can see that this length here, from there to there, is 60, okay? 60 is the same length from there to there. So all I got to do to work out A is go, okay, if I say 80 take away 60, it will leave me with 20, and that is my length A, 20 meters. So that length from here to here will be 20 meters. So A is equal to 20 meters. Now that I have found the unknown side lengths, I've answered question A. The perimeter is pretty easy to find. I can simply add up all the sides. So if I add up all the sides, P for perimeter is equal to 290. Our units are meters. If you did it the other way, where we know this was once a whole rectangle, which means if I pull out these side lengths, 50, and pull out that length, 60, it makes my whole rectangle. That means this whole length is also 80 meters, just like that side, and this whole length is also 65 meters, same as that length here. You could have just gone 80 plus 80 plus 65 plus 65 as well. Okay, question 2 says, using a calculator, find the perimeter of the quadrant to 2 decimal places. So have a go first. So always make sure you understand what the question is asking. We know perimeter is the border, so walking around the shape. So we have a curved part here, which is part of a circle. We've got to find that perimeter, that length, and then we add on these side lengths here. So 2.3 I can see is the radius of a circle, and this length here is also 2.3. We can see they are equal in length, and this is a quadrant, which means it's a quarter a quarter of a circle. Okay? So if I do the full circle, I've got a quarter of it. Okay? Which is what we mean by quadrants. If I had 2 quadrants, it would be half a circle, so a semicircle. If I had 3 quadrants, it'll be 3/4 of a circle, and we have looked at this. So first of all, focusing on the curve part, the part of my circle, the circumference, which means perimeter of a circle, I can use the formula pi times d, or pi d, or I can use 2 pi r. We know they are the exact same thing. We know the radius is half the diameter, so here I have a 2 to double the radius. Because I have the radius here, 2.3, I might work with this formula here, just to make things a bit easier. But that is for a full circle. Now I don't have a full circle. I can see I have a quarter of a circle. Also, this 90 degrees is telling me I have 90 degrees out of 360. If I simplify that, it gives me my quarter as well. Okay, so I'm going to say perimeter now because we don't have a full circle, and we also have to add on these side lengths. So the perimeter of this whole shape would be a quarter of, you can write it in words for now, a quarter of a full circle, which is 2 pi r. That's my full circle, so I want a quarter of that. And then plus these side lengths. I can call them just L and L. So plus L and plus L, which is just 2.3 plus 2.3. So I've got to find all of this, add it all together, and it will give me the perimeter of this quadrant, the quarter of a circle. So let's focus on finding that quarter of a circle. So I'll just focus on this part here first, and then we can add on the side lengths later. So perimeter will be equal to a quarter. So of in maths is times. So a quarter of, now I've got 2 pi r, so I can write 2 times pi, and r I can see is 2.3. If it helps, you can write it near the diagram just to clarify. Yep, it's half of the diameter. So times 2.3. Okay, so now perimeter will be equal to, we can put this straight into our calculator. The question said use a calculator. So you can go 1 divided by 4 times 2 times pi times 2.3, or let's just fix it up. Now, I can multiply 2 times 2.3. So double 2.3 leaves me with 4.6. So I have pi times 4.6. And the other thing I can do to make my working out more simple is I've got a quarter, because I've got a 1 on top, and everything, and this is all sitting on a 1. So 1 times everything on top is just the same thing. So pi times 4.6. 4 times 1 is just 4. So the trick is, whenever you are multiplying something with a fraction that has a 1 on top, you're just dividing by the number on the bottom. So I'm just dividing by 4. Now my working out looks a little bit neater. I'll enter this into my calculator. So pi button is here. On your calculator, you might have to push shift and then pi. So pi times 4.6. I might push equals first just to see what that gives me, and then I've got to divide that by 4. And I'm left with 3.6128, and we can see it's an irrational number, which means it goes on forever with no pattern. That's because pi is irrational. And the question said to round off to 2 decimal places. So to round this off, I would have 3.61. The number after 1 is 2. Because it's 4 or less, I'll just leave the 1 as it is. So P is equal to 3.61 centimeters. Now remember, this is just part of the circle. So I've just found the length of that curve here. That's what I've just found. Now I've got to add on the other sides, the L plus L. So I'll just continue it here because I haven't got room on the bottom. So perimeter of the whole shape now will be equal to 3.61. We can write centimeters later, plus 2.3 plus 2.3, or you can say 2.3 times 2, that's fine as well, plus 2.3, just squeeze it in. So perimeter is equal to, I add all of these up, you can use a calculator for this, we end up with 8.21, our units are centimeters. Okay, so the perimeter of this whole shape to 2 decimal places is 8.21 centimeters. Okay, the next few questions will involve our knowledge in area. So you can write this as your next subheading. And question 3 says, find the area of the following rectangle. Now the area of a rectangle, we have learned the formula area of a rectangle is equal to length times width. And we have learnt why. And this rectangle actually shows us why. When it comes to finding area, we are basically working out how many smaller squares make up a larger shape, in this case a rectangle. So yes, you could have counted all the squares individually, but we can see that the length is, if I count my units, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a length of 12. I don't know if it's centimeters or meters, so I can just say 12 units. And a width of 1, 2, 3, 4, 5, 6, 7, 8. 8 units. And that is all I need to work out the area. So area will be equal to 12 times 8. Area is equal to 96. Now I don't know my units, so I'll just write 96 units. Okay, question 4. A square has an area of 49 meters squared, or square meters. Find the side lengths of the square, find the perimeter. So have a go first. Okay, so you may have noticed that with this question, they have already found the area for us. So let's draw a square to visualize what we are dealing with. And we know a square has equal sides, which means when it says for A, find the side lengths, all the side lengths will be the same value, the same number. Now, I know the area is equal to 49 meters squared. So with that, I've got to find the side lengths. So the area of a square, the formula would just be just like a rectangle, length times width, but because they're all the same lengths, we say L times L. Now, the area I already know is 49 meters squared. So that equals L times L. So I've replaced A with 49 because that's the area. Now, if it helps, you can rewrite it like this. L times L is equal to 49. We haven't changed the question at all, we've just rewritten it. Now, you can solve this using an equation, but if you haven't learned equations yet, we can just do it mentally. And that is, what is a number times itself to give you 49? So the same number times itself to give me 49. Well, I know that 7 times 7 equals 49, which means L must be equal to 7. So for A, the side lengths would be L is equal to 7. And we know it's the same all the way around. And it's in meters, so just write the units meters. Now for B, find the perimeter. Now that we have found the side length, the perimeter is simply adding up all the sides. There are 4 sides with 7 centimeters. So you can go 7 plus 7 plus 7 plus 7. Or I can say P is equal to 4 times 7. So perimeter will be equal to 28 centimeters. Okay, we have found perimeter, which is length. So don't put a square there. We haven't found area, we have found length. Okay, question 5 says, name the following quadrilaterals and find their areas. So please draw these and have a go first. Okay, so let's first name these shapes. They're all quadrilaterals. We know a quadrilateral shapes with 4 sides, polygons with 4 sides, straight sides. And depending on their side lengths and other features or properties, we can name them. So this one here looks like a rectangle, but I can see it's been squashed a little bit. And it's also telling me that these arrows are saying they're parallel. So these 2 lines are parallel and those 2 lines are parallel. Those 2 lines are equal and those 2 lines are equal. So this would be a parallelogram. Okay, and we can see the angles in here are not 90 degrees. It's been squashed. So opposite angles are equal. So that's equal to that and that would be equal to that. And that's how I can tell it's a parallelogram. This one here, I can see it's got a pair of parallel sides. So these 2 opposite sides are parallel, and these 2 sides are not. So this one here is called a trapezium. So a trapezium only has 2 parallel sides, 1 pair. This one here is called a kite. And we can see a kite has 2 equal sides that are adjacent, so next to each other. So this side and that side are equal. And then it has 2 longer sides that are equal and adjacent. So these 2 sides are touching at a point as well. They're side by side and they are equal. We can see that by those dashes there. Okay, so now we have to find their areas. Now that we have identified what shapes they are, we should also know what formulas you use to find the areas. And we have learnt why we get these formulas. So a parallelogram, the area of a parallelogram is equal to its base times height. The The trapezium, the formula of a trapezium is a bit longer. Area is equal to half, and then we have A plus B, and then we times it by H, the height. You can write times by height or just write H. So that's the formula for a trapezium. And a kite, the area of a trapezium for a kite is half of X times Y. If you might have seen this written like this as well in other books, X times Y divided by 2, that's correct as well. Now we know in measurement, whenever we see B for base, base must belong to the actual shape. In this case, a parallelogram, the base can either be this line here or that line there, because I can see the height they're showing me is going from this line to that line. So these two lengths are equal, so you just pick one side. So this can be my base 3, and I can see the height, which is 8, is perpendicular to the base. That's the other thing we have learnt. Base and height must be perpendicular, which means they meet at 90 degrees, and we can see that angle there. So area is equal to, the base is 3 times the height, which is 8, goes from that parallel line straight up to the other parallel line. So area will be equal to 24 centimeters. We're finding area, so squared. So there are 24 squares that make up my area. Trapezium. Now trapezium, a little bit more complicated because we've got A and B and H, so 3 things to identify. Now this B here does not mean base. This means A and B refer to the 2 parallel lines. Okay, it doesn't matter which one's which. A is usually the one on top, but if you had B there, that's fine. And B can be the bottom one. But this B is just saying one of the parallel lines. Okay, and height. The height goes straight up from the bottom line to the top line, or from the top line to the bottom. Okay, it has to be straight up. The height has to be perpendicular as well. So we can see that the height is actually part of the trapezium. This 18, yes, it's the side length of the trapezium, but it's also the height. Okay, I can see it's at 90 degrees as well. So that is H. H is 18. Now that I have identified all these variables, I can work out the area. Area is equal to, so half. We know there's an invisible times there, so you can write that down if you want to. Now we must do A plus B first. So let's first substitute our values. So A is 14 plus B is 25. And then I times it by H, which is 18. So we've learnt with BODMAS or BIDMAS, we must do brackets first. So 14 plus 25. So that will be 39. So I've got half of, so 39 times 18. So area will be equal to half of, and I'm happy for you to use a calculator for larger numbers, so it's 702. Now at this point, you can put it into your calculator as 1 divided by 2 times 702, or all we're doing is area is equal to, we're saying half of 702, or 702 divided by 2. And we can do that mentally, which leaves me with an area of 351 millimeters squared. Okay, so I just wrote it, couldn't fit underneath, just wrote it on the side there. So that's the area of this trapezium. Okay, and for the kite, so the kite, we have to work out what X is and what Y is. And we have learned X and Y are the diagonal lines. So I can see with this kite, there's a lot of information. I've got this side length is 2, that's also 2, this is 5, I've got 7 and 3. I don't need all of it, I just need X and Y, the diagonals. Diagonals mean the length goes from corner to corner. So Y is the longer corner, which is 7, and X from this corner to that corner is 3. So the area will be half of, or half times, X, 3, and Y times 7. So let's do 3 times 7 first. So 3 times 7 is 21. So what is half of 21? Or I can say, what is 21 divided by 2? Which leaves me with 10.5, or 10.5. And our units are centimeters, and we found the area, which is squared. Okay, question 6 says, using a calculator, find the area of the following sector, correct to 2 decimal places. So we have learnt a sector is part of a circle, but the sector, these are always the radius. This is always the radii, because these two lines meet at the center of a circle. So if I did a full circle, okay, those two lines meet at the center. That's why it's a sector. Must be at the center, which means these two side lengths must be the radius. Now, we have learned that a full circle is equal to 360 degrees. So if I have part of a circle, I have a fraction of that. Okay, so we're using our fraction skills to answer this. Now, when it comes to sectors, we have learnt the formula, or the area of a circle, first of all, is pi r squared. That's the area of a full circle. But because I've got a fraction of it, we just have to say, okay, what is the fraction? So what angle do I have? So what angle do I have out of 360? Okay, it could be half, it could be a quarter. It just depends on what angle I have. So the fraction of the full circle. So that's the way we write it as a formula. And all it is, this is the angle given to us, in this case 120. So I have 120 degrees out of 360 times pi times r, I can see is 2, so 2 squared. Now this fraction here, 120 over 360, it can simplify to 1/3. So that's what I have, 1/3 of the full circle, which is pi times 2 squared. Now 2 squared is 4, so I might as well write that down too. Now at this point, you can just put it straight into your calculator. We can fix up our working out. I've got a third one on top, so I can write it like this, pi times 4, and then I'm just dividing by 3. Okay, so let's put this into our calculator. So pi times 4, I'll push equals, then that's a full circle, but I want a third of that. So divide it by 3, and I'm left with this. Now the question said to round off or correct to 2 decimal places. So I'll be focusing on these 2 decimal places. And the number after this 8 is 8. Because it's 5 or more, I must add a 1 to that 8. So my answer will be 4.19. So area will be, so now that we've rounded off, area is approximately equal to 4.19 centimeters squared. Okay, question 7 says find the area of the annulus shaded area to the nearest millimeter. Now annulus is just a Latin word for ring. So we can see we have a ring or like a donut, and it's formed by having a full circle, the area of a full circle, and cutting out the area of a smaller circle. Okay, so we've got to find the area of that shaded part. Now let's plan out what we need to do to work out this shaded area. If I can find the area of that large circle and subtract it, and subtract the smaller circle from it, so that smaller circle is just sitting inside, if I can cut that out or subtract it, it will leave me with that ring, that shaded area I need to find. So that's our plan. Okay, so I need to find the area of the large circle, area of the small circle, and then I can get the area of the annulus. So area of large circle, take away that, will equal that ring shape. Okay, so let's focus on the area of the large circle. Now, when it comes to finding the area of a circle, the formula is equal to pi r squared. We need the radius. So same with the area of the small circle, I'll be using the same formula, pi r squared. Now, I need to make sure I have the radius. I can see the 72 for my large circle, that is the diameter. So that's the diameter for the large circle. And the diameter for the small circle is 45. So I need to make sure I halve these to get the radius. So if I half these, the radius is equal to 45 divided by 2, which is 22.5 for my small circle. And for my large circle, 72 divided by 2 leaves me with 36. Okay, so I have found R for my small circle and my larger circle. So with the large circle, area will be equal to pi times 36 squared. Area will be equal to, now we can just enter this straight into our calculator. So pi times 36. Now there's my power button on this calculator. So power button squared, so power 2. And I get this. Now the question actually tells us to find the area to the nearest millimeter. So we're not rounding off to decimal places, we're actually finding the nearest millimeter, which means you go to the ones column and round it off at that point. So my number will look something like this, except before I just copy this, the number after the 1, which is 5 or 0.5, because it's 5 or more, I add a 1 to that 1 there. So it'll be 4072. So approximately 4072 millimeters. So that's the area of that whole circle. Now I've got to find the area of the small circle. So once again, pi r squared, area is equal to pi times r, which is 22.5 squared. So go to my calculator. So pi times 22.5 squared, so power 2, leaves me with this. Rounding it off to the nearest millimeter, there's my ones column, it's a 0. My number will look something like this. Just do a check. The number after that 0 is 4 or 0.4. Because it's 4 or less, I don't add a 1 to the 0, it just stays the same. So 1,000, so approximately 1,590 millimeters. So now that I've got the area of that large circle, I've got the area of the small circle. To find the area of the annulus, I just subtract the small circle from the bigger circle. So big circle, take away small circle, will leave me with that ring. Okay, so area of the large circle, so I have A for area, is equal to 4,072. Take away the small circle, which is 1,590. Area will be equal to, you can put that straight into your calculator, and we get 2,482 millimeters squared. So we'll put approximately because we have rounded off. So the area of that ring, the annulus, is there. Okay, question 8 says find the area of the shape to the nearest millimeter. So have a go. So question 8, find the area of the shape to the nearest millimeter. Okay, so once again, this kind of question involves composite shapes, whether we add a shape to another shape or subtract a shape from another shape. And always start off with a plan. Now I can see that it looks like I had a whole rectangle and then a part of it has been cut out. Okay, so the shape I want to find is that blue outline there. So it was once a whole rectangle, and then it looks like a piece has been cut out. Okay, and that piece we can see is a quadrant, a quarter of a circle. So if I can find the area of that whole rectangle, subtract what's being cut out, the area of the quadrant, it'll leave me with the area of the shape. So there is my plan. Area of the rectangle minus the area of the quadrant will equal the area of what I'm left with, that shape. So let's start off with the area of a rectangle. So the rectangle, if it helps, you can also draw it separately. It's got a length of 20 millimeters and a width of 10. So area of a rectangle I know is length times width. Area is equal to 20 times 10. So area will just be 2 times 1 is 2, add the 2 zeros, 200 millimeters squared. That's the area of the whole rectangle. Now I've got to find the area of that quadrant, that quarter of a circle. So there's my quadrant. You can see it's 90 degrees there. All I need for the area of a quadrant is the radius. And the radius, I can see this length from here to here is 10, which means this length is also 10, which happens to be my radius as well. So the radius is 10 millimeters. So R is equal to 10. And we need that for the formula. Now the area of a full circle I know is pi r squared, but I have a quarter of that. So I'll have a quarter of pi r squared, which is my full circle. So area is equal to a quarter of is just times pi times r, which is 10 squared. Let's fix up my working out. So I can write it like this. I know 10 squared is 100, so I can say pi times 100, and I'm just dividing by 4. A quarter of something is dividing by 4. Now we can put this into our calculator. So pi times 100, oops, and then divide it by 4, leaves me with this. And the question said to round off to the nearest millimeter. So once again, go to our ones column. So look at 78, but just do a check. After the 8, I've got 5 or 0.5. Because it's 5 or more, add a 1 to that 8. So I'll have 79. So 70 approximately, because we've rounded off, 79 millimeters squared. So I've got the area of the rectangle, the area of the quadrant. So the area of the shape, okay, will just be equal to the rectangle, take away the quadrant. And it leaves me with, that's the area of that shape. So area of the shape will be equal to 200, take away 79. Area will be approximately, because we have rounded off, let's write approximately 121 millimeters squared. So remember, that's the area of that shape here. Okay, our next area now is looking at some volume questions. So you can write this subheading. Okay, question 9, what is the volume of the following solid? Okay, so we can see the following solid is a rectangular prism, and we have learned how to find the volume of prisms and how it actually works. And this diagram here is actually pretty good because it's showing us exactly how we get volume. So to find the volume, we need to find the area of a cross section, and we have learnt the cross section is the same shape at the, in this case, the top, and it will be the same shape at the bottom. So the area of this would just be 1, 2, 3 times, so a length of 3 times a length of 2, which is 6. And that's how we get 6 cubes. That area tells us that there are also 6 cubes in my first layer. And it's showing us there are 4 layers, which means the height, which is the next thing I need, is 4 units, so a height of 4. So if I get the area of a cross section times it by the height, it gives me the volume. So rather than counting every cube individually, because volume means how many cubes in my space, so rather than doing that, we just find the area of the cross section. In this case, it was a rectangle, and then times it by the height. So the height is the distance or length from one cross section to the other one. So the volume for this one would be, for volume of any prism is area of cross section times height. That's our main formula. And volume will be equal to the area of this shape is a rectangle, so length times width, and then times by the height. So volume is equal to, we counted 1, 2, 3, so 3 times a width of 2, and the height is 4, there's 4 layers. So volume will be equal to 6 times 4, which equals 24. Now I don't know what the actual units are, so we just say 24 cubic units, which means there are 24 cubes in here that make up the volume, and we can see that. Okay, question 10 says find the volume of the following solids. I just changed prisms to solids because we know a prism has to have straight sides, okay? And this one here is not a prism, but we can see they all have cross sections. So have a go first. So remember, with each of these, because they all have a cross section, it'll be volume is equal to area of the cross section times the height. Area of the cross section times the height. Volume is equal to area of the cross section times the height. So they all have the same main formula, and now the area depends on the shape we have. So with our first one, we can see it's a cube, which means every side length, every edge is 10 kilometers. So volume will be equal to the area of one of those faces. So if I focus on the front one, what's the area of that front square? That's a cross section is a square, and I know I have the same square right at the back. And the space between the front square and the back square I can see is 10 kilometers. Okay, so height would also be 10. So area of the square would be 10 times 10. Actually, I can write the formula down for the actual square. So area will be length times length. That's the area of a square times the height. So volume will be equal to, and if you had, because height is also 10 as well, if you had times L, that's correct as well. But I'd like to put the height there just to see how it's a bit different in terms of the area of the shape. So then I've got 10 times 10, length times length, 10 times 10, and then times the height, which is 10. So volume is equal to 1,000 kilometers cubed. So we found that the volume. So it's saying there are 1,000 cubes in that large cube there. So it's a very large cube. Now this one here, I can see that they've actually told me what the area is. Here, that 5.18, it's saying 5.18 meters squared. So they've actually told me the area of the cross section. There's the area of that weird shape. Okay, they've actually told me that. So I already have the area, that is A. And I can see the same shape is at the back based on that shape I can see around here. So that shape at the front is also at the back. That's how I know it's got a cross section. So volume will be equal to, area of the cross section is done for me, 5.18 meters squared times the height. So what's the space between the front and the back? It is 3. So volume will be equal to, now you can use this, put this into your calculator if you don't know decimals yet, but all you're going to do, ignore the decimal for now. So I've got 518 times 3. So 3 times 8 is 24. Put the 4 down and add the 2. 3 times 1 is 3, plus 2 is 6, and 3 times 5 is 15. Now, because I ignore the decimal, a decimal is currently here. Because I've got 2 decimal places in the whole question, in these 2 numbers, I move it 1, 2 places. So you might remember this from year 7. So volume equals 15.64 meters cubed. Sorry, I just miscalculated here. 3 times 1 is 3, plus 2 is 5. So that should be a 5 there. Just making sure you're paying attention. Okay, and for our last one, we can see that we have a prism. All the sides are straight. The cross section I can see is a triangle. So this will be a triangular prism. The triangle at the front, there it is the same triangle at the back. So if I slice this, I'll see that same triangle all the way through. Okay, so I need to find the area of the cross section, which is the area of the triangle. I can see that front triangle, which has a height of 6 and a base of 5. So I find the area of a triangle, then times it by the height, the distance between the front triangle and the back, which is 10. There's my height, and I'm done. So volume is equal to area of a triangle. What's the formula for the area of a triangle? It's half base times height, or base times height divided by 2. Same thing. That's a B there. And then I've got to, once I find the area, I times it by the height, which is 10. So volume will be equal to, base is 5, part of my triangle, times the height, which is 6. And I've got to halve that. And then later times it by the height, which is 10. So volume will be equal to 5 times 6 leaves me with 30 divided by 2, and then times that by 10. Half of 30 divided by 2 is just 15, and 15 times 10 is 150 centimeters squared. So 15 times that 1 was 15, and add the 0. I'm sorry, not squared, cubed. We have found volume, so always check that. Okay, so the last section involves extended questions, so applications, applying our knowledge to the real world. And question 11 says, Sam's property boundary dimensions are shown on the right. So they're showing us his property boundary. So A, how many meters of fencing will he need to fence all but the front boundary? So there's the front. And B, if the fencing costs $100 per meter, what will the total cost be? So write this down and have a go. Okay, so remember, whenever you have an application, keywords tell you what you're trying to do. Boundary is another word for perimeter, okay? Dimensions, we know, are like length and width, and they're actually showing us the diagram. It's all measured in meters. Check our units as well. So how many meters of fencing will he need to fence all but the front boundary? And that makes sense because we don't usually have a big fence at the front of a house. The fence along the side of a house, or the sides of this house, a house is different to the front. Okay, so we got to find that perimeter, that boundary. Not the whole shape, just from here to there. The front is not included. So perimeter, so for A, perimeter will be equal to 74 plus 44 plus 75. And you should have gotten 193 meters. Okay, so that's the fence off 1, 2, 3 sides. Okay, if fencing, so now B, if fencing costs $100 per meter, what will the total cost be? Well, if we have 193 meters and each one costs $100, well, we just say cost will be equal to 193 meters times 100. So cost will be equal to, now 193 times 100, do it mentally, 193 is still there, add the 2 zeros, and it's in dollars. So we have 123, $19,300. So it's quite an expensive fence. And you can also write a final statement as well. So therefore, Sam will need 193 meters of fencing at a cost of $19,300. Okay, our final question for this session is this one. Tim made a geometric sculpture, so we can see the sculpture that he's made. If materials cost $2 per cubic meter, calculate how much it will cost him to produce the sculpture. So have a go first, and please draw this as well. Now, before you start this question, or make sure you understand what it's asking, what you have to do, and what shapes you're dealing with. So if materials cost $2 per cubic meter, so cubic meter is telling us how many cubes are there, meter cubes, in this sculpture. Okay, once we find that, we times it by the cost, which is $2 per cubic meter, and it will give us the cost, the total cost. So we have cubic meter means we're trying to find the volume. Okay, so find the volume of this sculpture. That's our first step. Now, if we have a look at this sculpture, we can see that there's a triangular part on top, or 3D triangle, and it's the same at the front and the back. So that's a triangular prism. It's got a cross section, and then these two bits here, they are rectangular prisms. We can see that, and they are the exact same length, 1 meter there, 1 meter there. So these two rectangular prisms are the same shape, so they will have the same volume. So if I find one of them, I can just double it. So I've got to find the volume of this triangular prism on top and the volume of the rectangular prism, and then double it. Okay, so let's start off with the volume of the rectangular prism, and I've put times 2 there to remind me I have to double it when I get my answer. If it helps, you can draw the rectangular prism separately so you can see clearly what we're dealing with. So I can see that I've got 1 meter by 1 meter. So I can see it's a square base, which means the cross section I'm going to focus on is a square, same square on top, and the height between the square and the bottom square and the top square is 4 meters. So there's my height. That's all I need to work out the volume of a prism. So volume is equal to area of the cross section, the area of the square, times the height. So volume will be equal to, well, the area of a square is just length times length, and then I've got to times it by the height, and the length I can see is 1 times 1. So 1 times 1, the height is 4. So the volume of one of these rectangular prisms is just 1 times 1, which is 1 times 4, so 4 meters cubed. Okay, but I've got to double it. I've got 2 of them. I found the volume of 1, so double it. You can go 4 plus 4, or just times that by 2. So the volume of both will be equal to, the volume will be equal to 8 meters cubed. So that is for both. I have found the volume of 1 and 2. Now I need to find the volume of this triangular prism that's sitting on top. And once I find that, I add it to my rectangular prisms to 8, and I've got the total volume. Now this rectangular prism, I'm going to draw it separately because I can see the measurements aren't clearly given to me. So I'll just draw it up here. Okay, so we know the volume will be equal to the area of the cross section times the height, okay, because we know it's a prism. So I've got to work out the area of that front triangle, which is the same as the back. All right, so to find out the area of a triangle, I need a height. And I can see the height here, from here to here, is 2.5. So that's got a height of 2.5. Now the base is down there. Base must belong to the triangle. So what is the length of that base? But if I go down here, I can see from here to here it's 3 meters. But then I need to go all the way. So from there to there, it's 3 meters, but I need these end bits. So 3 plus 1 on this side will give me 5. So the base from here to here would be 5 meters. Okay, so we had to work out that base there just by adding 3 plus 1 plus 1. Now that I've got the base and height of my triangle, the last thing I need for volume is the height, the distance between the front cross section and the back. So this length here. So what is that length there from the front to the back? Well, I can see if I go down here, it's the same length as that, which is, and I can see it's 1 meter because that was a square and they were the same. So the length here is 1 meter, which is my height from the front cross section to the back. Now that I have all of the information that I need to find the volume for this this triangular prism, area of the cross section times the height. So area, I'm finding the area of that front triangle will be equal to the base. So we'll write the formula: base times height divided by 2, area of a triangle, and then later I times it by the height. So volume is equal to base times height is 5 times 2.5, divide that by 2, and then times it by 1. So remember that capital H, height, is the distance from the front to the back, distance between the cross sections. Okay, so volume will be equal to, let's multiply 5 times 2.5 first. So 5, if I double 5, it's 10, so that leaves me with 12.5. And then I've got to halve that, and then times it by 1. I'll just continue it up here. So volume will be equal to, what is half of 12.5? Well, half of 12 is 6, and then half of 5 is 0.25. So do that one mentally. And then I've got to times it by 1, but I know that the height is just 1, so if I want to times it by 1, it won't change 6.25. And that is the volume in meters cubed of that's a cube there, of that triangular prism. So now that I have found the volume of the triangular prism and the volume of the 2 rectangular prisms, I just got to add them together. So I'll just write it here. So total volume, actually I'll rub out some. So total volume, or you can write volume of sculpture, would be the volume of the rectangular prism plus the volume of the triangular prism. So I'll have volume will be equal to 8, you can write meters cubed, plus 6.25 meters cubed. So volume will be equal to, 8 plus 6 is 14, and then the 0.25 just stays there, meters cubed. So that is the volume of the whole sculpture. Now, they're not asking me to find the volume, they want to know the cost. So if I have 14.25 cubes that make up my volume, and each cube costs $2, I just got to times it by $2. So cost will be equal to 14.25 times the $2. So I'm just doubling that number. So dollar sign now, I'm going to find the cost. So double 14 will be 28, and double 25 will give me my 50 cents. So the total cost of this sculpture will be $28.50. So therefore, it will cost, now what was his name? So it will cost Tim, we'll put his name in there, so it will cost him $28.50 to, we'll use keywords from the sentence, produce the sculpture, to produce the sculpture, to produce the sculpture. So get some keywords from the actual question. So this sculpture, even though it's large and huge, it's actually not going to cost him too much. So it might be made out of cardboard. All right, thank you.